Question 6 says that derive the formula for the curved surface area and the total surface area of the frustum of a cone given to us in section 13.5 using the symbols as explained. So we'll draw a figure first as shown in the screen and we'll be trying to understand it first. So basically what we have is a cone OAB with its base radius being R1, its total height being H1 and its slant height being L1. Now to construct a frustum, what we do is we cut it by a plane which is parallel to its base. So the plane that we are making use of is DC and that gives us a frustum ABCD. Now we know that the radius for the upper circle of this frustum be R2 as highlighted in the figure. We'll have to find the slant height of the frustum and we have taken that to be L and we have taken the height of the frustum to be H. Now, if we just focus on to the triangles, that is triangle AOP and triangle DOQ, we know that DQ is parallel to AP and so we can say that these two triangles, that is triangle AOP is similar to triangle DOQ. So now as these two triangles are similar, what we can derive from this is that the sides will be proportionate or to each other. So we'll take that DQ by AP will be equal to OQ by OP and will be equal to OD by OA. So we know that DQ is R2 as seen in the figure, AP is R1 and that will be equal to OQ. So OQ is the height which is left over. We know that the total height of the bigger cone OAB is H1 and the height of the frustum part is H. So we can find the length of OQ by subtracting these two and we'll get it as H1 minus H divided by OP and that will be H1. And that equals now OD. OD is the slant height of the upper cone which got created when we created the frustum part. So that can again be found out by subtracting the length of the frustum part from the total length of the bigger cone. So that will be L1 minus L and that is to be divided by OA, which is the length of the bigger cone, that is OAB. So we write it as L1. Now we can simplify it as R2 by R1 to be equal to H1 divided by H1 will be 1 minus H by H1, that equals 1 minus L by L1. What we can do is we can equate these two parts. So we'll write R2 by R1 equals 1 minus L by L1. So that implies L by L1 will be equal to 1 minus R2 by R1. That on simplification will give us R1 minus R2 by R1. So that implies that the length of the frustum part will be equal to L1 times R1 minus R2 divided by R1. Now that we have found out the slant height of the frustum part, we can go on to find the curved surface area of the frustum. So the curved surface area of the frustum part will be equal to the curved surface area of the cone OAB, the bigger cone, minus the curved surface area of the upper cone, that is cone ODC. So we'll have to substitute the formulas for these and we'll write it as pi times R1 L1, that being the curved surface area of cone OAB, bigger cone, minus pi R2 and we'll have to multiply it with the slant height of it and that will be L1 minus L. So now we will be substituting the value of L1 that we had got and that will be pi R1 times L R1 divided by R1 minus R2 minus pi R2 times R1L divided by R1 minus R2 minus L. So we'll get it as pi R1 square L divided by R1 minus R2 minus pi R2 times R1L minus LR1 plus LR2, and that whole is divided by R1 minus R2. So in simplification, we'll get it as pi R1 square L divided by R1 minus R2 minus pi, inside the brackets, this and this, that is R1L and LR1 will get cancelled. So we'll get it as pi R2 square L divided by R1 minus R2. So what we can take common from both of these terms is pi L. So what will be left inside will be pi L times R1 square minus R2 square, and whole is divided by R1 minus R2. So on simplification, we'll finally get the answer as pi L times R1 plus R2, and this will be the curved surface area of the frustum part, which is created from a cone. So the next thing that we have to do is to find the total surface area of the frustum part. So the total surface area of the frustum part will be the curved surface area of it that we have just now found out, plus the curved surface area of circle 1, which is at the bottom, and the total area of circle 2, which is at the top. So I'll repeat, what we have to do is we have to find the curved surface area of the frustum part, add it with the area of the circle which is at the bottom and the area of the circle which is at the top, that is C1 and C2. So we've already found out the curved surface area of the frustum, so we can directly write that total surface area of the frustum part will be equal to curved surface area of the frustum plus area of C1, circle 1, plus area of C2, that is circle 2. So we'll be substituting the formulas, and that will be pi L times R1 plus R2. Area of circle 1 will be pi R1 square, and area of circle 2 will be pi R2 square. We can take pi common, and what we will be left inside the brackets will be L times R1 plus R2 plus R1 square plus R2 square. And this is the total surface area of the frustum which was formed. And that's how we solve this problem.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.